Hi guys, welcome to the 5th PolyWalk video. This is variable growth rate, and what I did is I added the feature of that the start points all start differently and all this stuff grows at different speeds. So you can put a noise map on this stuff and it's gonna respect it. So we'll just watch I'm gonna take those points off. And you can see this is growing at a different speed. Like this guy's growing slower than this one, not by much, but it's all varied now. And let's walk through how that was done. So the first thing I got to do is I got to put up an ID for the communication network. So the communication network of these primitive IDs, not the original primitive ID, was the triangle ID at the center. So you can see each one of these centers represents a triangle. This new primitive ID 2 represents these primitives. Now the problem I face is I have to store in each one of these primitives, I got to store the children in a map. So I'm going to make a map variable. I'm going to set that to -1, and we'll show you why, because -1 can't really mean, there's no primitives with primitive ID -1. Now, what we're going to do is we're going to promote the generation onto the point, because that is a difference between these points. Because what we do is we blast all the geometry, we sort by the generation, so we know that the lowest generation is going to be the last vertex when we connect all of these. Now, you can't really see it, but all these got connected into a primitive. We're going to promote that primitive ID of the point. So this is the primitive ID, this is the triangle ID. We're going to promote that to the primitive that we just built. These are all primitives, they're connected, they're all in the same spot, hard to visualize, but each one of these points, they got connected. Now here's this build map. So we're going to use a wrangle code. Now for each one of these guys, we're going to grab the last point, which is right here. Then we're going to access the primitive ID, which is the triangle ID, which is the primitive attribute that we promoted right here, that connected all these primitives. So what that means is we can search for that primitive, we can grab the vertices, and what we can do is now we can loop through those vertices and we can access their primitive ID, which we promoted that onto that point, so we know which children they are. Then we're going to set a vector, and this code's a little bit sloppy because, oh no, this makes sense, yeah. We want all those -1s, because if there isn't a child, it's going to stay, like if there's no children, the vertex count's going to be 1 or 0. Like right here, this child, the vertex count is 2. Well, technically 1. And so there's only one child because, we subtract 1 right there. So there's one child, and then so we're going to set that value, but it's only going to go in 1 deep into the vector. And so that child will be written, so it'll be like for XYZ, we have maybe the ID, which is like 20, or we can put a number here. Like right here is that 966, and then it would be -1, -1. And then that stores into this vector attribute called a map. Now that's very important. Now we got to do a couple more things. We have to find the roots, and so the roots are, yeah, here they are, these red ones. These are the starting points of the system. And then so we're going to set that root, because we got to start this algorithm at these guys. So what we're going to do is we're going to fuse all these different connected networks up. And as you can see, I'm just going to flicker this so you can see all these different networks. So all these patches, they're going to get an attribute called class, which we're going to transfer over with a nearPoint function, very easy. And we're going to be able, for all these different sets, we're going to be able to set a random start frame in between 10 and 100. Then let's go promote both of those onto the primitive. We can add some noise, and then we do basically the same thing, taking that class. We have these randoms, each one of these patches, these sets of individual networks, they're going to be growing at different speeds. It's important to put this blend rate and the offset in here. This is going to be a little bit tricky to follow. Here's what these offsets translate into. As you can see, they're the same values. Well, what we have to do is, along one of these branches, we got to tally these branches up. So we know this guy knows the total of all these values down to the start point, which is, I believe, where are you? Oh, you're so tricky to see. Oh yeah, it should be right here. It's the start point. So this guy has to add up all these values, and as you can see, this is a tree structure. So how do we do that once that's started? So that's the random offset value. Now this is how I did it. I had help from an engineer to walk through this problem. Chris Allen gave me some pointers, and the biggest pointer was actually building that map first, because what this does is it's a recursive algorithm. So it starts at, for each one of the root primitives, visit the node and then pass in a value. So when you start, you don't need to add anything on the first primitive, so it's just 0. So we pass in a 0. And then we're going to process this node. And so when we start at, we'll say, this node right here, so 0. So now we're on this node right here. Or no, we're still on here. Then we're going to get the map attribute, where we're going to add these values up. So 0 plus 0 is nothing, or 0 plus whatever that value would be, maybe 5 or 10. I don't know why I can't. Where's oh, hit spacebar, took that out. Frustrating. So as you can see, this total got added. So you can see how the numbers changed. So we visit the node, we get the map, we add the value up that we passed in. What we do is and then we return the total. So we basically add the number up. So let me find a root node here. I know you're somewhere. Oh, there's one. Okay, cool. There we go. So 6 and 6. So there's the starting offset. So when you add 0 to 6, you're going to get 6. And then obviously 6 plus 12 is 18. So there you see it operating visually. 6 plus 10, 16. And then 6 plus 10 is also 16 on this one. And then this walks through. So the way we do that is by accessing the map of the attribute. So if we're operating on this primitive, we access its map attribute. That's some debug, it doesn't matter. And then so for each in the map value, I should have done this with the while loop, but it doesn't matter. So for each in the range, we're going to go to the primitive. We're going to get that primitive that in the map value that we stored. If it's not -1, we know it's a valid primitive, so we can access all the primitives and put that primnum in here. So that goes into the primitive. And then we can run again this visit node. So this is a recursive algorithm. And we're going to pass in that primitive so we know which one to go to, and we're going to pass in the total. And so that total was defined by here of what we added here. So we're taking 6 while we're operating on here. And so it's going to loop again. It's going to process this node. It's going to add the values to the R offset value, which is 16. It's going to return that total. And then it's going to look for a child again. And then it's going to find this one. And as you can see, it's going to keep on going. And so if it went down this branch, this branch, this branch, this branch, well then it's done, but it still needs to go through this for loop, so it's on the second iteration of the for loop, and it goes here, runs again, runs again, runs again, runs again. And then it goes to here, and then back to here. And so that's the recursive algorithm. This is what solved the problem of avoiding the adding variance into this and still keeping it without a simulation. So, you know, once those values are added up, I can compute the blend value. And as you can see, it's this R offset minus the blend rate. So it's 137 minus 32 minus the start frame divided by the blend rate. And then so that gives us a nice 0 to 1 value. Oh, and that's the attribute start frame. Don't mind this because that was a constant value. And then it just plugs into the animation module. So you can see how this is module. So now that that's done, I could make a totally different growth module for these triangles, and I can make them flip or transform in different ways, but it's still adhering to that blend. And so that's sort of how I like to work in these module areas. So this we're going to put in its own group, and we're going to call it variable speed. So quite, it took a while to figure that out and get that working. Maybe 16 hours of plugging away on it. So again, thanks to Chris Allen for the help, and I'm going to upload the latest OTL and this video. So thanks for watching, and I hope you enjoyed. Thanks.